Everyone, so for today we continue with chapter 2 for our subject, which is Introduction to Compiler. For this chapter, we will look into what is a compiler, what are the phases of a compiler, because compiler have several phases, and also the implementation technique inside the compiler. So for this slide, I will discuss on the first two, which is what is a compiler, as well as the phases of the compiler. Let's look into what is a compiler. By definition, is a program that translates a source program written in some high-level programming language into a machine code. So what actually is that? Compiler actually is a program that written as if you write a programming code. Yeah. So it can be written using a high-level language like Java. Also can be written in machine language. It's a binary code. Okay. Also can be written in the forms of assembly language. It's a program. Okay. So what does this program do actually is this program will contain a grammar that will translate your high-level language, your Java programming code, your PHP code, your Python code into a machine code. Why is it we need to convert it into a machine code? Because our computer can only read, can only compute instruction in machine code language. So if you have a high-level language like Java, our machine cannot compute. So it needs to be converted into a machine language. Only then it can be processed. So we need this program called compiler to convert our high-level language program, the program that we write in Java or whatsoever, into a machine code. Okay, so this compiler is actually a code to generate a machine code. Machine code that is able to be understood by a computer, so that computer can process it. Okay, so compiler is a program. Okay, so program that is written in a high-level language or assembly language or a machine language. Okay, right. So that is a compiler. Okay, so machine code is a language that is understandable by our computer, which is in the binary form 01, 01 and 01, because our computer, our processor can only process a data in the form of binary numbers. That is why the program, the system, the application that we write in a high-level language need to be converted into machine language. Okay. So the generated machine code can be later executed many times, again different data each time. So we can use it again and again. The code that we generated, we can use it again and again. Here is the illustrative examples of a compiler. For example, you write a program called Hello World in C, in C language. Then you need to process this program. In order for it to print out Hello World, it needs a compiler. You normally, when you write a program, you need to compile. So when you compile, actually what it does is it actually converts it into a machine code. Okay, convert it into machine code. That what we see as a general. Okay, but actually inside the compiler itself, it has several phases that we will look into later in this slide. Okay, so the conclusions here is the compiler actually having our high-level language program like a C, Java, COBOL, Prolog, Python, PHP, C++, and many other language, high-level language. We construct this program using this high-level language, and we need a compiler okay, to check the error, and at the same time actually it convert our high level language into low level language. Low level language is assembly language or machine code. Okay, so the compiler itself here, the compiler itself actually is a program. Okay, this program is written in a different language. It can be in high level language, it can be in machine language, it also can be in assembly language, and it can in many form where when we have a different machine like a Sun microsystem, we have a Mac operating system, they have a different compiler, and they have a different compiler. The advantage of a high-level language over machine or assembly language. Why we need this assembly language? Why do we need this high-level language? Because when the first time computer is introduced, they are using a machine language 0100101 like that, and then they have increased it. Okay, they have increased. They use an assembly language. Okay. Assembly language is more human readable language. Instead of using just a 0 and 1 digit, they have come up with a symbol, a short form. Like if you want to do addition, they have a command like add. If you want to do a multiplication, they have replaced a code with MULT, that will stand for multiplication. Means that they have a symbolic representations of operations. So it is more easier for human to develop instead of using 010101. And then with the advancements of the technology and also the capability of a programmer, they have introduced a high-level language. High-level language means it is more human readable. It is more to a natural language, our spoken language. Okay, that is where you see our Java code. We have a while, if. So by the keyword while, you already know actually the code is for repetition. By using the keyword if, you already know the word is for condition. So the code, they make the code, they develop the code more to the natural language, our spoken language. Okay? That is high level language. So what is the advantage here? The advantage here is when you use a machine language, it is difficult to work with and difficult to maintain, because all of the the character there is 0 and 1, just 0 and 1. It's hard for you to memorize, it's hard for you to understand, and it might also tend to error. Yeah. Second, with a high-level language, you have a much greater degree of machine independent and portability. What does it mean here? Using a high-level language like a Java, Python, you can use the same syntax of Java code, the same syntax of a C++ code in any machine. It is portable. It is machine independent. Means that even you are using your language in a Mac, Apple machine, it is the same syntax you use in our machine tools machine. Okay, so you are using the same syntax of language. The syntax will not be changed. So it is machine independent. Okay. High level language also may support data abstraction through data structure and program abstraction. Okay. By using high level language, if you ever learn about the object oriented before, it use and data abstractions mean that you can make the code more general and reuse it again. But this function could not be done using a machine language. Machine language and assembly language is insequential. Means that if you want to declare something that is repeating, you have to do the repetition in your code. Okay, but not in high level language like a Java or C++. You can declare it once and you can just call that function if you want to use it. You don't have to write, to copy the whole code all over again. Okay, Next is you do not have to retrain application programmer every time the new machines. So because the syntax of the Java code is the same, so you don't have to retrain the application programmer. Okay, so they can just use the same syntax of a high-level language. What about the disadvantages here? The programmer does not have complete control of the machine resources such as a register, interrupt, and I/O buffer. If you are using high-level language, you don't have any control of the memory allocation, the register of the processor, the system. You just need to know about the interface, the high levels operations of your program. Okay, and you cannot have a control over the memory allocations. Second one, the compiler may generate inefficient machine language program. Okay, so when you have this high level language, it would be depends on the compiler that is created by a programmer as well. So if the compiler is good, is efficient, then the program that you create can generate a more efficient machine language. So it will depends on the compiler, the program that generated by uh, a programmer, which is a compiler itself. You want to know whether the compiler is good enough or not. Okay. Third one, additional software. The compiler is needed in order to use a high-level language. Okay, when you use a high-level language, you need an intermediate, a converter. You need to have a compiler in order to use a high-level language to convert it into a machine-readable code. So that is the disadvantages of using high-level language. But today's I think this drawback, disadvantages is overcome with a new technology, with lots of libraries created. So it's not it is not a problem anymore. Compiler versus interpreter. Compiler and interpreter is used interchangeably. Sometimes they use compiler to mean interpreter. Sometimes they use interpreter to mean compiler. If you can see in this still figure, the first one is compiler, second one is interpreter. They are using the same input, which is the high level language. Okay, the input is high level language. But the difference is on the output. The output for compiler is a program. Okay, it's a program, is an instructions in a lower level language. In this case is an assembly language. Whereby for interpreter, the output is the program output. Means that the interpreter will manipulate, will compute the instructions and produce the outputs of the program. So that would be the difference. So compiler produce instruction and program, whereby the interpreter produce the program output. Okay, next is compile time error and a runtime error. I guess most of you already know what is it, compile time and runtime error, because when you learn a programming language, you will come across these two terms, these two concepts. So compile times error is occur when you compile your program, okay? And a runtime is when you run your program. So during the compilations of your program, what the compiler do is they translate your high level language into a lower level language. That is what the compiler do. Okay, so during the compile time, they only will detect the syntax error. Means that they only detect the missing structure or an inappropriate structure of your code. But during the runtime, they will not check the structure. After the structure is complete, is checked, then only then you can run the program. During the runtime, they will check other logical error. For example, in this case, is division by 0. If you look into the code on the runtime error, x equals to a minus a, there is nothing wrong for that code. There's nothing wrong, no syntax error. The structure is correct. And y equals to 100 divided by x semicolon. Okay, structure wise it is correct, nothing is wrong there. But logically in a mathematical computations, a number cannot be divided with 0. So that is what we mean by logical error. But syntactically means that the structure is correct. Okay, the same thing if you do the runtime normally deal with semantic. Semantic means the meaning of the code. While during the compilation, it normally check for the structure of the program. For example, if you have a English word, okay, I like to eat rice. That is the correct structure. Okay, that is the correct structure. And then you have another sentence. I like to eat handphone. Structure-wise, it is correct. I like to eat handphone. Nothing wrong with the sentence. But semantically means that if you look into the meaning, it is incorrect. So that is what it means by structure and logical error. Okay, so runtimes normally detect logical error. Okay. Now we want to look about big C notations. Okay, C actually here is for compiler, not for C programming language. No, it's a compiler. C stands for compiler. So for this slide, actually, the most important information here is to tell you that a compiler is a program. As I mentioned to you, it's a program that is written in, can be written in any language. It can be written in high-level language. It can be written in machine language. It is also can be written in assembly language. Okay, so compiler will also it is machine dependent, means that it will depends on the machine. If you use a Sun microsystem machine, they have a different compiler. If you have you using a Mac machine, they have a Macintosh machine, they use a different compiler. Okay, so the most important here, this is the notations. Okay, C Java goes to Mac, C Java goes to Mac at the second one, and C PC goes to Java. What does it mean here? Okay, so what does it mean here actually? In this big C notation, we want to know in what language the compiler is written. Okay, on what machine is the compiler running, and also to what machine it is compiled to. Okay, it is compiled to. Okay, so for the first one, the first A here, the big notations in A, it will mean that it is a compiler for Java. Okay, compiler, Java compiler, translated into a Mac machine. Okay, written in Mac machine. Okay, for B, it is a Java compiler. Okay, translated into a Mac machine on a Sun microsystem. So it is different. The first A and B, both is a Java compiler, but one is running on Mac machine, another B is running on Sun microsystem machine. So the compiler is different. C is running on a PC. Okay, they want to convert it into a high-level language, Java. Okay, and it is written on Ada language. Ada language. Here is more examples. Okay, some sort of exercise, but I give the answer here. Okay, for the first one, an Ada compiler. This is a compiler, Ada compiler, which run on the PC, run on the PC, and compiles to the PC machine language. Second one is also an adder compiler, which compile to the PC machine language, but which is written in adder. Okay. Third one is adder compiler as well, which compile to the PC machine language, but which run on a Sun microsystem. That is how you read the big C notations for the compiler. Now we already know what is a compiler. So compiler is a program that is written in any language, high-level language, assembly language, or machine language. So the purpose here is to translate the high-level language, the program that we write in a high-level language, into a machine-readable language. So the compiler itself, in order for the compiler to translate our high-level language into the machine-readable language, there are several phases or steps that the compiler do. So what are the phases? Okay, there are 5 phases altogether. So we have the first one, a lexical analysis. Second one is the syntax analysis. Third one is global optimization. Fourth is code generation. 5 is the local optimizations. So we put the source language, with high-level language, we name it as a source language, and at the end, the output is actually our target language, which is our machine-readable language. So these are the phases. Okay, for the lexical analysis, if you can see in the graph here, in the figure here, the output for the input for the lexical analysis is our high-level language, which is a Java program, C++, or other languages. So the output for lexical analysis is called token. Okay, after we done with the lexical analysis phase, the output for this phase is tokens. Okay, so this token will be used in next phase, which is syntax analysis. So we use the syntax analysis. So the output for the syntax analysis would be atoms. Okay, so it can be atoms or in the form of tree structure. Okay, either it is atoms or a tree structure. I will discuss with you what is atoms after this. Okay, next phase is also a global optimizations. So the output here is an atoms. What the global optimization do is just to optimize the code, so it can be omitted, means that you can exclude it in the process. So global optimization is used to make sure that your program can run efficiently. Okay. Next is the code generations. This is where your machine code will be generated. Okay. And here is where the output will be instructions. The compiler output is instructions, so the output here will be instructions. The next phase is the local optimizations, another phases of optimization. So optimizations here is also optional. It is with the same purpose of the global optimization, where it is used to optimize your code to make sure that your code can run efficiently. Okay, so the output will also in the form of instruction. So your target language will be in the forms of lower level language. Okay. Okay, now we move to the first one, lexical analysis. This is the first phase. The lexical analysis sometimes is called linear analysis. That is another name for lexical analysis. So lexical analyzer take an input of word or sentence and split it into token. So we call it the input, each statement inside your high-level language, we call it as a word or a sentence. If you learn a discrete structure, we also call it as a sentence. Means that if you, in your code you have, for example, in C++, you are using C out hello world. So that particular code is called words or sentence. Okay. In your program, you might have many codes or many statements. Okay, so we in this process we will split it into a tokens. So lexical analyzer is used to split this word become a token. So what is a token? Token is a sequence of character with collective meaning. So sequence is a sequence of characters. So what is a character? Character can be A, B, C, D, E, a symbol, plus sign, minus sign, can be a number. Okay, that is a character. Okay, for example, I have a word, I have a sentence, hello world. So that is counted as 2 token. Hello, 1 token. World, another token. I have another words or sentence, integer x equals to 0. How many tokens? So I have 5. Integer x equal 0, semicolon. So altogether is 5 tokens. Another one, x equals to x plus 1, 5 tokens. X equal x plus 1. So 5 tokens. So that is what it means by tokens. Tokens is a sequence of character with collective meaning. Okay. Alright. So when counting the number of tokens, so omit the white spaces and comments. So we don't include the white space and a comment when you want to count it as a tokens. Alright. So what are the combinations of words and sentences? What can be a tokens? Okay. So words and sentences can be the combinations of following. It can be a keywords like while, void, if, for, integer. Okay, that is the keywords in a high-level language. Then we also can have identifiers. Identifiers are declared by a programmer. Any identifiers, variable that you declare, constant that you declare, x, number, customer, any variables that you declare, we call it as an identifiers. Operators, plus, minus, multiplication, divisions, equals, assignment statement, that is counted also as a token. Numeric constants, we have 1, 2, 3, 12.35, any numeric constants. Character constants, okay, a single char or string that enclosed with quote, any char. Sometimes we put a gender in char, female, male, so that is a character constant. Special character, okay, like a bracket, $sign, semicolon, colon, and also comments. So ignore by subsequent phrases. So this must be identified by the scanner. But this one, as I said, is not included in the output. So these are the token that we can get from the high-level language, the category of tokens, that you can get from the high-level language. Okay, on the next slide here is the example how actually they split our sentence, split the sentence that you write in high-level language into a tokens. Okay, so for example, you have sum equals to sum plus unit, multiplications, divide multiplications, accumulate sum, multiplications, 1.2e dash 12 semicolon. That is the statement, that is the sentence, the words. Okay, so the solution here, they will split it into a token. So each of it will have a different token, different category of tokens. So how many tokens altogether? We have sum, we have assignment statement, equal statement. We have another sum, plus, unit, multiplications, a constant number, 1.2e dash 12, and a special character, semicolon. So this is the output for the first phases, syntax analyzer. So they will split our sentence into several tokens. Sorry, the previous one is a lexical. Okay, now it's a syntax analyzer. Okay, syntax is about a structure. Lexical is based on the character. Now it's a syntax. Syntax concerns about the structure of your code. Okay, so the lexical just now is called a linear analysis. Now we have syntax. Syntax we normally call it as a parser. Okay, parser. So what this parser will do, the parser will check for a proper syntax, make sure there is the proper syntax. For example, a semicolon. If you are missing semicolon, then there will issue a error saying that missing a semicolon in your code. Issue appropriate and error message. This is also a parser task. Determine underlying structure of the program. So basically, parser will deal with the structure of your code, what is missing, what is not. For example, if you want to declare a variable that have a structure, for example, the structure would be you need to declare the data type, integer, variable name, then operator, equal signs, number, and end with semicolon. So that is the structure. That is the grammar for writing declarations of variable. So if you're missing one of it, then it will issue an error message. For example, you miss out the semicolon, they will produce and issue the message saying that missing semicolon is missing, something like that. So the output of this phase is a stream of atoms. Now we want to know what is atom after this. Also, or a collections of syntax trees is either a stream of atoms or a collections of syntax tree. Okay. So what is an atom? An atom is atomic operation or one that is generally available with one machine language instruction on most target machine. What does it mean? See, atom, for example, there if you have that instruction is in that instruction add comma A, comma B, comma C. Okay, so that actually is the an atom, examples of an atom, whereby the meaning is to add A and B and store it result in C. So you will learn it when you do assembly language. It's a kind of assembly language instruction. So add comma A, comma B, comma C actually will mean adding A and B and store it result in C. So that is one atom. So an atom here means that any operations, for example, multiplication, move, store, is a one atom. Atom means an operations, one operations of your code. That is called an atom. Okay. Okay. Now we see in this example, this is a Java statement. A equals to B plus C times D is a Java statement. Okay. In this statement, it can be divided into 3 atoms. Okay. One is for the operation of C times D. You need to calculate C and D first. C times D first. Okay. So you do multiply C, D, and you store it in the temporary temp1 memory. Temporary memory temp1. After that, the next atom is you add B with temp1. Temp1 is the result of multiplication of C and D. Now you want to add the result with B. So that is a second atom. So the result of these additions will be stored in temp2. Next one is after you have these operations, B plus C times D, the result in temp2 will be assigned to A. So you need another atom called move. Means that you move the value inside temp2 to A. So you are assigning the value result of temp2 to A. Okay, this is the atoms. 3 atoms for this single statement. The second phase also, instead of atom, the output also can be in the form of syntax tree. There's tree structure. as in this figure here, as in this structure. So here you have assignment statement first. A will be the result of assignment. So A will be the operations. The node here normally is the operator. The leaf part normally is the operand. Yeah? So C and D is the operand. So C and D is multiplications. Okay, so the result of these multiplications will be added to B. Okay, so the result of these additions will be stored in A. So this is a syntax tree structure for this Java statement. Okay, another example for the while loop. Okay, for example, while A less than or equals to B, A equals to A plus 1. So these are the atoms. You can split the atom into several atoms here. The first one is because they are using while here, so in the assembly language, they will deal with a level in order to control the repetitions. Okay. Um, in this slide, I will not teach you how to convert this statement into assembly language. I will do that in another lecture. Another lecture that specifically to learn how to convert your high-level language into assembly language. Okay, in this lecture, I just want you to understand the process of compiler first. Okay, so this is the compiler. So at this stage, don't worry if you don't understand how to convert it into assembly language. I just want you to understand what are the phases inside the compiler itself. I will do another lecture just to cater on how to convert high-level language into assembly language. Okay, so this is several atoms that executed from that we can generate from this high-level language. Okay, like for example, they create another variable test A. Okay, this is the operator less than B. They put in the level 2, then they jump to level 3. So under level 2, they add A with 1 and store the result in A, and then they jump back into level 1. So this is the process of repetitions, if you can see. Okay, the process of repetitions. Okay, then they change the level into level 3 if it is completed. So this is the way you convert the high-level language into assembly language. So these are the atoms executed from this high-level language. Okay, another examples of the Java statement here for if statement, but this one I show it in the forms of a tree structure. So remember, for this phase, you have two output, either in the form of atoms, collections of atoms, series of atoms, or in the form of tree structure. Okay, so this is an if statement. So for the if statement, they have two here, if and else. Okay, so if less than A plus 3 is less than 400, so this is the first part of the if, and then A equals, if there is A equals to 0, so else is A times A equals to B. B equals to A times A. So this is three parts of your if statement using a tree structure. Okay, sometimes they are added phase on the semantic analysis, whereby many compiler actually do include this semantic analysis. Semantic analysis is to check for logical error, as I told you. Okay, so in this phase, the data type is checked and the type conversion is performed. So what is the data type? You normally know that any variable that you declare have a data type: integer, real number, whole number, you have a double. So at this stage, they normally check for the data type, whether it's correct or not. Then if not, they will do a type conversion in this stage, in this phase. So semantic error also will be detected at this phase, like at divisions by 0. Okay, the third phase here is a global optimizations. This phase is optional. Okay, it is the purpose is for to make sure the object program more efficient, to make sure the program can run smoothly. So how? How by removing the redundant and inefficient and unnecessary instructions. So how? Okay, for example, in the statement there, statement 1 go to level 1, then statement 2, statement 3, level 2 go to statement 1. So in this statement actually, statement 2 and statement 3 is unreachable. Means that after you do statement 1, you were asking the code to go to level 1. So means that you are jumping statement 2, statement 3 there. Okay, so statement 2 and statement 3 actually is unreachable. Unreachable means that you did not execute it, never execute it. So statement 2 and 3 should be removed. During this phase, statement 2 and 3 will be removed so that your code will run smoothly. You don't have to execute that particular code. Okay, another example here is a for loop. In this case, your y inside the for loop is not changed. Even though your for loop is repeating from I to 100,000, the value of y is not changed. So the assignment statement to x does not have to be in the loop for this case. Okay, next one. This is the fourth phase. The fourth phase is about a code generation. This is where your high-level language is translated into a lower-level language. So in the code generation phase, atoms or syntax tree are translated to machine language, which is a binary. Okay, but normally in the example, we show you in the form of assembly language. Assembly language is another form of a lower-level language because it is readable. It is more readable. Okay, code generator is responsible for register allocations. Okay, so this code is actually for register allocations. Means that you already generate the atom. You already generate for each of the atom is to represent certain operations. Now you want to know how to allocate it inside the memory. Because when you only can compute it when you put it inside the memory allocations. Okay, for example, an add atom might be translated to 3 machine language instruction. Just add. Okay, when you want to do additions of 2 numbers in the code generation, that actually translate it into 3 machine language instructions. First one is to load the first operand into a register. So in order for you to calculate 2 numbers, first thing is to store the first variable into the register first, the memory. Only then you can do add operations, second value to the value inside memory. Okay, and then the result will be stored in another temporary memory. So add the second operand to the register. The third step is to store the result inside temp1. In this case, it's temp, not temp1. In this case, it's temp, means that another memory allocations. Okay, so this is the last phase. It's a local optimization. So this phase is also optional. It's also to increase the efficiency of your codes. So this is also often called as machine-dependent optimization. So it depends on the machines. So one of the example might be a load or store optimization. So we see what is the examples of a load and store optimizations. Okay, for example here, we have this code assembly language code. code generated from our high level language. Okay, if you see the star here, they said that star here in the code, they got the star here. Those marked with star in the comment can be eliminated without changing the effect of the program. So means that these two code actually, if it is not there, it's also fine. It will not change the meaning of the code. Okay, if you don't want to store the R1 inside TEM1 and load the R1 TEM1 also is fine. The code will generate and run and produce the same result as well. So this is another way of removing inefficiency, removing unused code so that your program can run smoothly. So at the end, we only, instead of 6 lines of code, you only have 4 lines of code. Okay, you might see it is a small changes, but if you have 1,000 lines of code and most of it will have something like this, it will actually slow down the running process and it slow down your program. When you want to run the program, it might slow down the speeds of your program. Optimization is also an important issue, although it is optional. It also important to increase the efficiencies of your code. That is the all 5 phases of the compiler. So we have discussed each of the phases, what is the input and what is the output of each of the phases. We also has covered what is a compiler, the advantages and disadvantages. Okay, we also has covered what is interpreter and compiler. Okay, what is a compile error and also a runtime's error. On the next lecture, I will look into what is the implementations technique of the compiler. So I'll see you in the next lecture. Thank you.